Good afternoon. Thanks everyone for joining us after a long day of sessions. It's been a super exciting day. We're really happy to be here this afternoon talking about IoT. My name is Sam George. I run the Azure IoT efforts within the Cloud and Enterprise division. I also want to thank everyone that's joining online. This is my tall friend Steve. He should be the one presenting cloud and Windows, but it's the opposite. So go ahead and introduce yourself.
Yes. Hi everybody, I'm Steve Teixeira. At 44 years old, I'm finally almost not self-conscious about my height anymore, so I really appreciate that, Sam.
Sure, yeah, you're welcome.
I know at 5 p.m. your choice is between cocktails and us, and thank you all for being here. Those of you that are attending via the web, we trust you've already cradled the beverage of your choice, and so with that, let's roll.
All right, let's do it. Okay, we are going to, one more. There we go. Okay. So today we're going to be talking about the overall IoT opportunity. If you haven't been living under a rock, you probably heard about the Internet of Things and what a big opportunity it is. We're going to sort of reiterate that. We're also going to talk about the plans that we've got across both Azure and Windows for IoT. Microsoft is extremely committed to IoT. We think it's an incredibly important opportunity. And it's something that you're going to see a lot more from us going forward.
Yeah, we've talked about IoT for a while, but IoT is not really a new thing necessarily. We've been doing embedded for many years, and often people will come to me and say, this IoT thing, like I've been sending data from my devices forever, and I've had all these little devices and been working with boards and embedded things a long, long time. So why are we having a new conversation about IoT? Why is it worthy of this room filling up with so many of you? And I think it's a few different things. One is the cost of hardware in a lot of domains is kind of asymptotically going to zero. Like literally, there are some cases where you can get the marginal cost of producing a new piece of hardware over a large manufacturing run is almost negligible. So that's just made it very easy. We can crank out hardware today in many domains almost as cheaply as we could crank out software in the past. The other thing that's changed is the pervasiveness of connectivity. It used to be back in the day that connectivity was low bandwidth, very, very slow, and it was very, very expensive. It was very hard to get a high quality, high bandwidth connection. Today, between 3G, 4G mobile data, as well as broad Wi-Fi coverage, data's almost there, and you can kind of depend on that for building new solutions. Tools are much simpler than they have been in the past, whether we're talking about the software side through Visual Studio or through a lot of what's going on in the open source space, or even through the hardware side, through things like Arduino and Raspberry Pi that are just making it very easy for people to develop hardware, software solutions, and the advent of the new cloud-based solutions so that we can marry all these together. It's no longer just about these devices in the world kind of working independent of one another. It's these devices connected to one another, connected to the cloud, and producing a solution that really exceeds the sum of all the parts. So all these things, these kind of new trends generate these new solutions, and people are seeing the value of these new solutions, which is kind of fueling the demand for more, and it's become this innovative virtuous cycle.
So the world of IoT in 2010, just 5 years ago, looks a lot different than the world of IoT in 2015. You see a much richer ecosystem, and we think this is accelerating considerably, especially right now. We think by 2020, this will look even dramatically different.
There we go. Now, there's some laws of physics in our space, and in the first graph, you see Moore's law, and probably most of us in this room are kind of either talk to people about this or we're the year-over-year beneficiary of Moore's law, building software solutions that take advantage of the fact that computers are getting increasingly capable year over year. Because transistor density doubles, that machine can do a little bit more every time that doubling occurs every 18 months to a couple of years. On the far right side of this slide, you see what's called Kumi's law. Kumi's an economist who I think working over at Stanford these days. And this is a little bit different than Moore's law. This isn't about transistor density. This is about power. And if you see the irregularity of this curve, and check out the beginning date of this curve, It's like the late 1940s. Since the late 1940s, our ability to do instruction processing for a particular unit of energy is kind of doubling about every year and a half. And so what that means is if you run the numbers on that, you end up with a machine in 10 years can do twice the work with the same battery of a machine today. So about every 10 years, we get about double battery efficiency based on the compute load. And in the middle, there's this little thing called Metcalfe's law. Bob Metcalfe's this guy that invented Ethernet. And he came up with this law that says that the value of any communication network is proportional to the square of the number of participants of that network. So every time we add another participant to that network of communication, the value kind of grows by another square. And we could think about this in terms of IoT or things a little bit more future-y, but I like to think about this in an old school way. If you think about the telephone, the telephone became a super valuable communication network when you could rely on the fact that everybody had one. And I think we're heading that way with IoT, where we can rely on the fact that things just know how to talk to each other and communicate to the cloud.
There are a lot of estimates about how big this is going to be. Some of them are, very grandiose. Some of them are conservative. Gartner estimates that there'll be 25 billion connected things by 2020. And IDC is estimating a $7.2 trillion impact on the economy. Whatever it is you believe in your crystal ball, we are convinced that we are in the midst of the next generation of computing, and it's going to be big either way. So let's talk about what Microsoft is doing for IoT.
Yeah, one of the reasons why Sam and I both really like working in this space is he and I work together a lot to try and figure out what can we do that's comprehensive, ranging from the smallest devices through to large devices through to massive hyperscale cloud, enabling our customers to really build solutions that matter to the world today. So on the Windows side, which is where I spend most of my time, we come from 20 years of history in this space through Windows Embedded, through Windows CE, some of our past work in automotive, lots of different device categories. So we've kind of had an opportunity to see this space evolve over time. We've made a bunch of mistakes on the way that we've learned from, and so we're eager to kind of bake all those learnings into what we're doing today with Windows 10. One of the things that we'll focus on throughout several presentations on IoT on Windows at Build this year is one platform. And you heard Terry say that earlier today. It's kind of one platform, dependent, no matter if it's HoloLens or Raspberry Pis or Windows Desktop or phone. And you can extend that to the IoT editions. Whether you're building, and I have some Raspberry Pis that both Sam and I will show you later, but whether you're building something for this little tiny board or whether you're building something for a PC, phone, laptop, or some MRI machine, ATM, point of sales terminal, it's the same platform. It's the same developer platform that you're using. It's the same driver model. It's the same application model. And it's Windows. So you know that it's ready to go in enterprises. It's manageable. I like to say it's enterprise ready, but it's also maker friendly. The fact that it's got this kind of enterprise level infrastructure built in, but we're working really hard to make the developer platform very, very accessible to you so that you can easily construct solutions. And one of the exciting announcements that we made at the Windows Hardware Engineering Conference last year is that the small Windows IoT Core Edition for the smallest class of devices will be available free for both commercial as well as non-commercial device builders.
Thanks. So on the Azure side, we're obviously very interested in helping customers build cloud-based IoT services and solutions. We have a set of services today that customers are already using in broad IoT deployments that I'm going to cover today. And then we have a rich roadmap that includes solutions and finished apps. All of these are easy to provision, to use, to manage. They provision in minutes. You pay as you go. You scale as you need. And very importantly for IoT, these solutions in our cloud are globally present. Because when you talk to customers, a lot of their IoT deployments are either now or will be global scale. And customers don't want to create one solution for every region that they're in. We're putting a big emphasis on end-to-end security and privacy. There was a talk earlier today by Clemens Vasters about IoT security fundamentals. We, of course, have all the industry best practices in our toolbox, and we have some ideas for how to take it even further. We will support Windows in a first-class way, and there's a lot of great things that we have planned on our roadmap. We also support all the rich set of devices and operating systems that exist. We sort of have a tagline that it's the Internet of Your Things, and that you can extract value from your things. And so we have rich support for embed, a bunch of versions of Linux, iOS, Android, and some other real-time operating systems. So let's talk about Azure. I'm going to cover Azure for the next few slides, and then we're going to go back to Steve, and he's going to cover Windows in detail. OK. So I'm going to cover IoT device and cloud patterns, the patterns that we tend to see again and again in IoT solutions. I'm also going to cover the set of services that we have today and how customers are using them. I've got a couple customer stories that are fun to talk about. And then I'm going to talk about the Azure IoT Suite and what we're doing with that. All right. So IoT is, since it's nascent, since it's a new thing, and in some ways, of course, it's old new wine because M2M's been around for a long time, but there are some forces that are interesting and are creating this phenomenon we call IoT. But when you ask someone what IoT is, you tend to get a lot of different answers based on how many people you ask. And so we found it really useful in Azure when we're talking with customers to boil down an IoT solution in terms of the patterns that we see and the value that customers are seeking to extract from IoT. It's a good way to sort of clarify what we mean by IoT and what we're doing for it. And so we boil it down into really three constituent parts. The first part, of course, is around device connectivity and management. The second is around analytics and finding insights into IoT data. And then operationalizing those. And the last is having them connect into your business and being able to see and interact with these IoT solutions. And I'm going to cover each one in detail. So I'm going to start really simply with an empty cloud and a set of devices. The devices that you see over on the left-hand side are running real-time operating systems today, driver-based operating systems, Linux, Windows, Android, iOS, and we expect this to sort of proliferate. As I mentioned, we do consider that this is the Internet of Your Things, and so sort of come as you are. We also have a cloud over on the right-hand side that I'm going to fill up with the patterns that we see in IoT, as well as the solutions that we've got. So our first step in the journey is to talk through device connectivity and management. It seems like my clicker's dying. My Internet of Things isn't working. Thank you, Steve. All right, so device connectivity and management. Actually, I'll just stand over here and do this. Save Steve some time.
I was going to be your clicker, but
yeah,
fine.
Totally. It would get
no,
a
I don't
weird.
have a job.
That's right. So device connectivity and management. So some devices actually communicate directly with a cloud gateway. There's a very common pattern. Today, we have a service for this, Azure Event Hubs. It's an extremely high-scale telemetry ingestion service. You basically send it messages over HTTP or AMQP, which is the Advanced Message Queuing Protocol. Each event hub supports 1 million unique publishers and supports over 1 gigabyte per second of ingress. We've had this in service since the beginning of the year, generally available, preview before that. Today, on average, we're doing about 18 billion messages per day worldwide through all of the event hubs that we have. This is changing pretty rapidly. About a month ago when I was presenting this, it was at 10 billion. So we're seeing a very sharp increase in the number of both devices that are connected as well as other services that are connected, because you can use event hubs for other things, including telemetry from websites and things like that. We're doing about 60 terabytes per day ingesting into Azure worldwide through these IoT hubs as well. So this is an interesting pattern where devices are sending telemetry to a cloud gateway. It's not the only pattern. In fact, some devices don't belong on the open internet. There's some devices that are very, very, very low powered, where if you put them on the open internet and receive commands from any inbound traffic, you're probably not going to like what happens next to that device. So a very common pattern that you see in IoT is that of an intermediate field gateway. And this is as much of a pattern as it is a device. So for example, we consider a cell phone to be a field gateway. And there's customers that are delivering solutions over Bluetooth LE to sensors on devices that connect through a smartphone. There's also, of course, industrial strength routers. And field gateways form an interesting security boundary as well. They can provide a sense of a capability of isolation. In the security talk, we talked about this pattern we call service-assisted communication, where the field gateway is responsible for the isolation of those devices. Another interesting pattern that we see is that field gateways do protocol adaptation and translation. So M2M and IoT have been around for a long time, as I said earlier. There's a lot of protocols, including custom ones that customers have invented or have used. A lot of them don't belong on the open internet. And so protocol adaptation is a really interesting pattern for extracting value from those devices that have already been deployed. So this is sort of the first part of this device to cloud patterns, and customers do find value in this. And like I said, many of the examples that we've got today that I'm going to be talking about use this pattern of a cloud gateway. But there's additional needs that we have in IoT. You have the need for command and control, to be able to issue a command to a device and to be able to know whether it received it. You need to be able to keep track of the identity of all of these devices and preserve that identity when you're replacing devices. You need a device registry that includes all the capabilities and assets and things like that that the device has. And you also need device management. As we said in our security talk, what you can't update, you can't secure. And so being able to update operating systems and firmware and software that's running on devices is very, very important in IoT. And of course, it ranges in, your security needs will of course range, but we think device management is a very, very important part of IoT. So I'm excited to announce that coming with the Azure IoT Suite that we'll be previewing this year, we have an additional service that'll be available with the IoT Suite called the IoT Hub. And there's a talk on this as well this week. So the IoT Hub supports bidirectional device-to-cloud connectivity. It will support up to 10 million devices. So it's sort of an extreme scale IoT ingestion service and command service. It supports command and control. It has a device registry as well as maintains device identity. And it will support device management. And so you'll be able to manage your devices, which is really important. When you start getting to the scale of IoT, you don't actually want to go around and flash devices because there's a lot of them. It'll support HTTP and AMQP as well as MQTT through an extensibility mechanism.
And this also enables these interaction patterns, right, Sam, where one device might receive some signals, send that to a cloud service, and the cloud service can maybe predict that something is going to go wrong. Correct. And have some other devices act accordingly.
Absolutely. Yeah. So as part of our commitment, we're not just building cloud gateways and cloud components, we're also delivering SDKs for devices. So we'll have an open source agent framework that'll be available. It runs on a variety of real-time operating systems, a variety of Linux variants, Windows, of course, Android, iOS. And like I said, this will be an open source project where we'll continue to innovate. It's easy to use. It's not required. This is just something that makes it easy to get started. We support standard protocols on our cloud gateway. So the way this is built is there's a set of cross-platform C code that we've got, as well as like any good cross-platform code. We've got an OS abstraction layer with a set of OS bindings. And the nice thing about this approach is that to move to another platform, all you have to do is create a new OS binding. An example of what we abstract in the operating systems are things that are different, like memory management and threading and networking and things like that. And then we'll provide a set of rich APIs on top, both C APIs, .NET APIs, Java APIs, as well as a Node library for JavaScript APIs. The C API, we're providing one to run in very, very memory-constrained devices. Our C API actually runs in kilobytes of memory, not megabytes of memory, so very, very small, and yet has all that rich functionality. There's a lot of functionality built into this: batching, retry, extensible encoding, extensible serialization, and things like that. All right, moving on. So Most folks don't wake up in the morning and say, I want to connect a bunch of devices to the cloud just for fun. There's something that they want to get out of it.
I do.
Well, Steve does. And there's, well, not most folks. So on the device connectivity and management, there's a lot of interesting things companies are doing already by just monitoring remote devices. A great example is fleet management. If you can monitor where all your fleets are, or where all your things are, you can keep control of them. But what we see is that customers, the value that they're starting to extract out of IoT starts to really shine when you get into analytics and then operationalizing those analytics. So let me give some examples. For example, in fleet management, there's a really interesting thing is, whereas if you know where all of your fleet, if you know the routes your fleet are traveling on, and the incidents that your fleet has on those routes, like when things get stolen, you can start doing intelligent routing and traffic routing and things like that. The pattern that you tend to see in this stage of our journey, looks like I'm going to have to go back to the keyboard. Thank you, Steve. The first stage of our journey in analytics and operationalized insights is where you're finding the interesting things, the interesting insights into your data to either power new services or improve those things. So we have a rich set of services available today: Azure HD Insight for MapReduce, Azure ML, which is our unique approach to machine learning, Power BI for rich visualizations, as well as Azure Data Factory, and just announced today Azure Data Lake for rich pipelining and data warehousing. Companies use this to find those insights. I'll give an example here, which is ThyssenKrupp, which is an elevator company. They have 1.1 million elevators worldwide. And for each one they have a bunch of different models that they service of those elevators. And for each one of those elevators, they had a set servicing schedule. Well, it turns out that if you know things like how much it was used and how much weight was in it and the operating temperature of things, you can using machine learning, you can much more accurately predict how much servicing it needs, and in most cases reduce the amount of servicing while providing better uptimes and offering uptime guarantees. So that's a good example of finding those insights. It's not just enough to find those insights. Once you have those insights, you actually have to operationalize those. You need to do something in real time. We have two services today for this. We have Azure Stream Analytics, which is a really cool service on complex event processing that has a really nice, simple SQL syntax where you can treat an extreme volume telemetry scale as if it were a static table and issue SQL queries that includes tumbling windows and averages and things like that. And then you can go and save those on to blob storage. We also have Azure HD Insight Storm, which is simply Apache Storm as a hosted offering. So this is really interesting because everyone thinks Azure is the Windows cloud. Azure is very, very friendly to open source and Linux. It's a great growing workload that we've got. And Azure HD Insight Storm is a great complex event processing framework. And so we fully support that in our IoT solutions as well. And then the last part of our tour around the analytics and operationalized insights is, so that pattern works really well, that complex event processing works really well if you're dealing with homogeneous sets of things like elevators or a fleet, and you know what you're looking for. When devices in the real world start to form hierarchies and graphs, things start to get complicated, like where there's logical parent-child relationships. So imagine, for example, if you're doing building maintenance for a company the scale of Microsoft, where you've got buildings all over the globe, campuses all over the globe, and each campus has a collection of buildings, and each building has a collection of rooms, and each room has a collection of sensors, which they really do, for all sorts of things from temperature to movement to whatever. And you want to implement a centrally managed system for doing things like turning on the lights when a critical amount of people are in the building. To do that, one approach to do that is to tag every single sensor and then to somehow be able to aggregate sensors. A much more natural way to do that is to build an object model and to take that high volume telemetry scale and bind it to that object model and have that object model be able to be distributed throughout a cluster. So today we announced Service Fabric, which is our next generation platform as a service. It powers a lot of the services that we do, including Event Hubs, and IoT Hub, and DocumentDB, and SQL Server, and Bing Cortana, and a whole bunch more. And it's a massive scale service that elastically scales up, and we think it's very, very important for the Internet of Things in this particular pattern. And it allows you to run sort of distributed business logic across all of the realized state of your IoT devices. So moving on to the next phase of our journey, the last phase, you of course need to be able to visualize data coming from these solutions and control these solutions. These solutions don't exist in a vacuum, they exist in businesses. So for example, when you've detected that an elevator needs servicing ahead of schedule, it's not just about knowing that, it's about opening a customer relations record. It's about rolling a truck, it's potentially about ordering a part. And so there's a workflow that's required. So we support a bunch of services for this, from Dynamics to BizTalk servers to notification hubs. We also have rich third-party extensibility for all sorts of other business process workflow. And then, of course, we have app service and websites and mobile services and a set of rich services. So this kind of gives you an idea of how we see IoT and sort of the end-to-end that we have, the end-to-end view that we have on IoT and what customers are doing with it. So if we move on. So these are the services that we've got today. We've got these set of services from machine learning to stream analytics to HD Insight and Data Factory, and customers are building on all of these today. And I'm going to go through a few examples, and then I'm going to talk about how we're taking this to the next level. So the first stop on our customer visit is that of Rockwell Automation. So Rockwell's a great company. It's been in business for a long, long time, and they're making their journey into IoT with us. So Rockwell has a deployment, an IoT deployment, for remotely monitoring gas and wellheads and doing predictive maintenance on those. And they have a lot of really interesting things they can do, like they can tell maintenance history over time, they can schedule service visits before anything happens. And so sort of a pattern that you'll see again and again in IoT is around predictive something, predictive maintenance, predictive stocking, using the cloud to predict and drive efficiencies that weren't possible before. If we go on to the next one, this is a fun one. The Stanford Linear Accelerator is doing a project with us as well, where they're streaming IoT data through Event Hubs into Stream Analytics to be able to predict using machine learning when components are going to have problems and to service those ahead of time. If we go to the next one, so no Azure IoT presentation would be complete without Connected Cow. This is a true story. So we have a great partnership with Fujitsu. Fujitsu is very much into IoT. They have a lot of rich examples and rich products already for IoT, from their eco dashboard over to being able to grow fruits and vegetables in hydroponic labs controlled by machine learning. They have another one, which is Connected Cow. And I love Connected Cow because to me it really illustrates the innovation that we're going to see in IoT and the unpredictability that we're going to see in IoT. Okay, so here's how Connected Cow works. So it turns out when cows are only in estrus for a very short window. And if you miss that window, you have to wait. And so what Fujitsu found was that if you put an industrial-grade pedometer on a cow and monitor its steps, you can predict using machine learning. You can predict with a very, very high accuracy, about 98%, when it's time to make more cows. Turns out that's very important. And it also turns out that 2% of false positives tend to be when the cows got loose. And so you kind of want to know that too. So Connected Cows is a great example from Fujitsu. This has actually been deployed to, I think it's 10 farms in Japan with really significant herd production improvements.
Very randy cow farms.
Yes.
Yeah, got it.
So that's Connected Cow, and that really sort of illustrates the breadth for us of IoT and the unpredictability. So for learning more at Build, we've got a few talks that happen today. They will be available on demand. The Microsoft Architecture for Internet of Things, IoT Security Fundamentals. We've got a great talk on Event Hubs, as well as Stream Analytics and Azure ML and Power BI. I encourage you to check those out. So we've also mentioned that coming soon is the Azure IoT Suite. I'm going to talk a little bit more about that right now. So today what customers are doing is they're taking the Azure IoT services, and they'll go and provision quickly an IoT hub and a Stream Analytics instance and connect them together. And we think we can do better. We think we can make it so that, because we see a repeated pattern of use cases that customers are doing, from remote monitoring to asset management to predictive maintenance. And what we're going to do in the Azure IoT Suite is allow customers in the Azure portal to simply go and provision those directly. And we'll orchestrate all the services. If you're familiar with the Azure Resource Manager, these are Azure Resource Manager templates that get provisioned, and we do any code customization that's required. These are also finished apps, and so they include a set of web assets for monitoring and managing and things like that are then also customizable. Because one of the things we found is that customers really want these sort of finished apps, but then they also really want to customize them. And so Azure IoT Suite is sort of the best of both worlds there. It also provides simplified and predictable billing, and so it's very easy to model out your COGS, especially as you grow to scale. And then finally, the nice part about this is that the same thing that you do your proof of concept with will scale up to those 10 million devices or beyond. We will include a free edition of these for a certain number of devices so that if you're a maker and you want to get started with Azure IoT, it'll be super easy to do. If you're a business and you're doing a proof of concept and you want to sell a concept, it'll be very, very easy to do. And then the nice thing is that when you decide to move forward with a pilot, it simply elastically scales and you pay for as you go, as opposed to I started with something to prove a case and now I have to switch systems. Okay, so let's go one more. All right, so I'm going to switch to a quick demo. I'm just going to log in here. Can we switch? This is them, not me. All right, so I've got a couple boards here that you see. I have an ARM board. I'm sorry, I have a Freescale board running Mbed 3.0. We have a lot of great partnership going right now with ARM to power Cortex-M class devices that are literally shipping in the billions today.
So this is running a little RTOS.
That's running a little RTOS, that's exactly right. And this is running our open source agent framework. We also have a BeagleBone Black running Ubuntu Snappy. So we're also partnering with Ubuntu Canonical on Ubuntu Snappy. They have a very cool little IoT operating system that uses a novel approach to software updates using containers. And then, of course, we have a Raspberry Pi running Windows 10. And Steve's going to be talking a lot about that and showing some deeper demos. And so we've got this, and then over on the other screen, we've got a little bit of the assets that we're putting together as part of the larger Azure IoT Suite that'll allow you to provision simulated devices, a whole bunch of different devices, and download our software agents and things like that. So for today, I've got a very simple set of 3 devices, and I'm going to switch over to it. Oh, it looks like my authentication timed out. There we go. OK. So we have a set of devices. So this is sort of a little fictitious scenario where each one of these devices represents a vending machine that's local in the area. And it turns out that usually around this time of year that you can see on the bottom, sales for some reason spike. It's almost like there's a whole bunch of people here. And so these really simulate a set of vending machines. And each one of these vending machines, of course, gets sold out pretty quickly. And I can simulate, what's interesting here, is I can simulate this little button here. As I click on it, it's actually sending, in a second, it's going to send data up to Azure. And you'll see our counter increment. Might actually have to refresh that. There we go. Our counter's being fussy right now. It'll catch up in a second. And then what I can do is I can actually go back into this and issue commands back to the device. And this is actually using an IoT hub. which will of course support those 10 million devices, and this will support rich grouping and tagging and batch commands and all that. But today I'm going to start with something very simple, and I'm just going to set a new price a little higher because my vending machines are emptying a little too fast. And over on the ARM device, you're going to see the price change. Oh, we got a new battery, great. And it's not right now, and I'm going to find out why in a second.
It's a good thing I'm going to show our rich suite of
Yeah,
designing
exactly.
tools for IoT devices.
Yes, one of the things that we'll have that Steve will cover is a great Visual Studio integration with IoT. This board might have frozen. I'll tell you what, I'm going to come back to this. I'm going to reset the device before we're done. If we can switch back to the slides. There we go. The battery's working again. We have a great talk on how to interact with the IoT Suite with the IoT Hub from Elio DiMaggio. I believe this one's on demand, so there's a rich set of demos that you can go and check out. And with that, I'm going to turn it over to Steve.
Thank you. So let's talk a little about Windows. I'll start with an announcement. It turns out that as of 36 minutes ago, we posted the images of Windows 10 IoT Core for both Raspberry Pi 2 as well as Miniboard Max. So at least that's what I was told was going to happen before I got on stage. So we'll assume that all went according to plan, and you'll be able to go up there. Please, again, use your hotel's Wi-Fi instead of the building Wi-Fi to get all those disk images. So yes, we're terribly excited to finally it's been a couple years in the making to get Windows 10 IoT Core out, this small version of Windows, and I'll talk a little bit more about the attributes in just a moment. Running on devices like the Raspberry Pi that you saw up here on stage, as well as Intel's Miniboard Max, which is an x86-based development board, also low cost, a little bit higher powered. It's not done. It's open for your feedback, as a matter of fact. One of the things that we kind of mindfully wanted to do is get the operating systems done enough to be able to enable folks to build real devices and do real workloads, but then also to not wait, to be able to get it to you as soon as we get it to that point so that we can get some feedback that we can use to prioritize our own work here. And maybe I just need to press it really hard. I think I'm going to try that.
I can switch for you, too.
So when we talk about Windows in the IoT space, we think about a few different things that Windows 10 brings that are different than what you might find with other operating systems in the space. One is this idea of a single consistent platform. Here we go. And again, one operating system that scales across devices, whether it's a single board computer or whether it's a complex set of IoT devices at very large scale. The ability to run universal Windows applications. One of the things that you'll see in a few different presentations throughout the conference is the ability to literally take the same application and simply change the target from my local machine to my phone to my Raspberry Pi board to a Windows server and have that same application run across this broad range of devices, even to an Xbox or a HoloLens. The other thing that we've done is converge the Windows driver model with universal Windows drivers. For years, being a hardware developer in the Windows ecosystem was probably more difficult than it needed to be, because if you wanted to support your hardware on Windows, desktop edition of Windows or Windows Embedded Standard, there was one driver model that you would use to go do that. And then if you wanted your hardware to be supported for Windows mobile devices, for phones, that was a different driver model. And then if you wanted to build small devices, maybe on Windows CE, that was yet another one. And so I apologize that we made you guys write multiple different drivers to kind of get one piece of hardware working in our ecosystem. But I'm happy to say that we're well on the way to getting that addressed. So now one universal driver will scale across all of those different platforms. And finally, the ability to bring new capabilities to devices. You just heard a bunch of great information about how these devices need to interact with the cloud to build real valuable business solutions. At the same time, we want the devices themselves to be awesome too. And part of building awesome devices is I don't just want devices necessarily that are sitting passively in the corner. I want devices that I can talk to. I want devices that can see me, that can understand my gestures. I want devices that can look at my face and identify me visually, as opposed to me having to offer some manual form of credentials. Windows devices are secure. Enterprise-grade security. We bring that same security infrastructure that you would expect to find in a Windows server or a Windows Enterprise desktop machine, and we bring that even to these Raspberry Pi machines, bringing technologies like TPM for secure boot or for BitLocker to be able to be present on these small IoT devices. I've got a friend who's kind of I wouldn't call him a hacker. Rascal is probably the term he would prefer. But what he'll do is he'll go look for an IoT device, and he'll go, oh, that's a pretty cool device. Pop off the plastic, pull out the SD card. Let me see what I can do with it. Put the SD card in the computer. Wow, this isn't even BitLocker. I can do whatever I want with this. I can root it. I can put some software on it. And so one of the interesting things about IoT in a lot of these kind of public device scenarios is nobody around this device is a trusted user. So you have to be careful about security, not just information security from a bit credential standpoint, but physical security of the device. People can tamper with the devices and do things with them that you probably don't want them to do with them. And the ability for mobile devices to host multi-role profiles. So if I think about a handheld that I might use in a retail scenario, it would be really great as a retailer if I can kind of provision one set of handhelds, and based on whoever the user is that picks up that handheld out of the charger, they can get the right set of apps and they can get the right user interface, no matter whether they're the manager or a clerk, or perhaps even a shopper that wants to go do a wedding registration or something like that from one range of devices using multi-role. Finally, Windows devices are born to be connected. They're connected out of the box. Connected to peripherals. There's a retail session on Friday where you can learn about the broad range of retail peripherals that Windows will support out of the box. So for example, you want to build a point-of-sale solution that incorporates a cash machine and a receipt printer and a barcode scanner. A lot of these things today now are just USB peripherals that you plug in and they light up and work on all editions of Windows. Windows devices are interoperable. Earlier today, some of you may have seen Gavin Gear talk about AllJoin, which is a major investment we're making in Windows 10. The idea that devices shouldn't have to conform to some particular walled garden ecosystem in order to work together and interoperate, whether in the home or in a business. Devices should, they want to be free. That you should be able to have a world where when I buy a couple different devices from 2 or 3 different manufacturers, they should just know how to work together. We should all speak the same protocols. In some ways, the fact that today we even think that's novel shows that we're still evolving in terms of maturity, but we'll get there. And our investment to get there is AllJoin, an open standard to be able to enable devices across operating system to work together locally and connect themselves up to the cloud. Because these are Windows devices, you deploy them like Windows devices. You manage them through MDM or through System Center or Intune, just like you would Windows devices. They can participate in Windows updates. So you kind of get all those management, update, security features that you would expect from Windows devices. And they're ready to be connected to Azure IoT to build out these bigger cloud-centric, data-centric solutions. Now, we've had a journey to get to where we are. What you see here is not the London tube map, but rather it is a lane for each of the previous embedded operating systems that we sold, embedded standard, the regular version of embedded handheld, and some interesting stations we hit along the way. Back in 8, we were really excited that we converged the operating system kernel. We kind of had one set of developers writing one set of codes that would make up the operating system kernel. But then we would take that kernel and add different things to it for the different Windows editions or for Xbox or for phone. In Windows 8.1, we were able to land on a converged application model. So we were getting to the point where, hey, I can build one application and start to get this working across different screens. And finally, on Windows 10, we've landed in the place where it's actually the same bits. This is actually the same set of bits, the same set of drivers, the same set of applications, all working together to form one comprehensive set of solutions. Now, in the device space, we also have this Windows Embedded Compact, or CE lane, that I would portray on here. Few different interesting releases along the way. Now, I think CE still has some high value for customers because it does things that Windows 10 won't do. So for example, if you need to build an operating system that has some hard real-time constraints, or you need an operating system that has, incorporates those constraints, CE is the way that you would still do that. So if you're doing some industrial device that has safety constraints that says, no, really, within 10 milliseconds, the arm has to stop or it cuts the human next to it in half, those kinds of things, yes, you want to build those things on an operating system with real-time constraints. What's more, there's a huge ecosystem of software, hardware, drivers built on CE. Those will continue, and we are investing in tools to enable a lot of those CE codes to move over to Windows 10. I talked a little bit about this at the Windows Hardware Engineering Conference last month and demonstrated some of the tools that we will use to enable developers to kind of migrate along the way. Now, last year at this conference, I also announced this Windows on Devices program, and we started with the Intel Galileo board. And I'm just curious, how many of you in the audience, did any of you get to try out this Galileo? Handful of folks in the audience. That's cool. So yeah, we were really excited to get Windows going on these smallest class of devices. And now we're seeing this Windows on Devices, again, is just folded in as a part of Windows 10. So Windows 10 just naturally enables me to target this small class of device. Windows 10 IoT comes in 3 editions. So as I talk about them from the outermost down to the innermost, the outermost is for the largest class of devices. And effectively, it's a version of Windows Enterprise that has the IoT bits necessary for customization, to lock it down to particular apps, to lock it down to particular peripherals, so that you can take what is effectively an instance of Windows and make it a vending machine, or make it an ATM machine. The system requirements are that of the desktop Windows system requirements, and it supports x64, x86. The next smaller edition of Windows is for mobile devices, and this is based on Windows Mobile. So it follows the chassis requirements of the Windows Mobile operating system, follows the system requirements in terms of RAM and storage of the Windows Mobile operating system. It includes the mobile shell. So if I'm building mobile apps, I have the ability to use the Windows Mobile shell, which Joe B. showed you earlier today, and runs on the ARM architecture. And then finally, the smallest is Windows 10 IoT Core. Some of you may heard the term Athens used to describe this operating system. That was our internal code name, but just wanted to connect those dots for you. This doesn't have a shell. The shell for an IoT Core device is the application that you write that represents the personality of the device. It may or may not have a video screen at all. It may be some machine that works in a closet or sits on a wall somewhere and doesn't have video interaction at all, or it may be something that drives a fairly large screen. It doesn't have any first-party MS applications, so there's no travel and there's no edge. None of those pieces of software are present on this device. It's the software that you write, plus all the standard operating system components, including my ability to support universal application and drivers. It will run in as little as 256 megabytes of RAM for a headless device, and in as little as 2 gigabytes of storage, which is enough to hold the operating system, all the apps that you would write for the operating system that of a reasonable size, and then some data for those applications that would fit in. All of that will fit within that 2 gigabyte envelope, and it is supported in either x86 or ARM. Now, few things in addition to these core operating systems. Windows updates come with all of these. My ability to use Visual Studio tools to target all of these, again, works across the broad range of devices. I can create I talked to you a little bit earlier about these new user interfaces that we want to build. That is supported across the operating system envelope. Talked a little bit about AllJoyn, and you heard Sam talk quite a bit about Azure in terms of how Windows folds into the Azure device graph. There we go. Remember in the movies when people would click, they would do this thing? I feel like that. OK, I think I went past one. This is where you would go to find your copy of a Windows 10 IoT Core image for either MinoBoard Max or for Raspberry Pi 2. Go to windowsondevices.com, and that will take you to the right place. And also, you'll find not just the OS images there. You'll find a bunch of information about the operating systems. You'll find sample projects. You'll find a link to a site on GitHub where we've released a whole bunch of both documentation and projects as open source, so you can kind of start to build some cool stuff. You'll hear some talks that will show some of these projects throughout the course of the presentation, or throughout the course of the conference, and I'll hit on a couple in a few slides. But now I would like to go to a demo. So let us please go to the laptop here, which I think is input 8. And so I've got a Visual Studio. Actually, thank you, Visual Studio. So what I've got here is I've got a Visual Studio universal application. This is an application that theoretically I could run on any Windows device, but I'm going to run it on my Raspberry Pi. Let me show you this Raspberry Pi really quickly. If we can switch to the document projector. My goal is to give the AV team a real workout. It's going to happen. OK, so I've got a cool one, but I just want to show you the bare board for just a minute, kind of introduce you to this bare board, this Raspberry Pi 2. So a couple key components. There is power that I use to power the device. It comes in the form of micro USB. I've got video out, HDMI video out, so that if I want to project video, I can do that from this device. I've got Ethernet. I've got USB ports. I can connect a camera to this device. There's a serial port on board with this device. There are a bunch of I/O pins here along the top that I would use to connect hardware and then drive that hardware via these I/O pins. And it's running a Broadcom ARM-based processor. So let me switch away from this board, and let me show you this kind of very cool board that's in a nice plexiglass case. So this is exactly the same Raspberry Pi cord, but in a nice case. And I've got a little shield that goes with it, if I can show you that. So then I've got a little weather shield that's wired to this. And this weather shield has sensors on it that will take the ambient barometric pressure and the ambient temperature and the ambient humidity. And I can read those things through I2C on the I/O pins on the Raspberry Pi. And then I can do interesting things with my little homegrown weather station. So now let me head back to Visual Studio. Very nice, quick transition. And I want to just show you a little bit of the code for this application, just to give you a feel for what it requires to build something like this. So in this case, what we've done is I've taken this weather shield, and I've got, I want to show you a little bit of the code to set this up. So what I've done is I've got this GPIO controller class, and this is built into Windows. So GPIO is a built-in capability of the Windows Universal Platform, or the Universal Windows Platform. I get the default GPIO controller. There is only one in this case. And then using that, I can then start to configure, read and write the GPIO pins to be able to begin a conversation with this particular shield. And so kind of doing some initial pin configuration, writing some data to the pins. And once I've done this is kind of the one-time configuration for the device. Once I've kind of configured this device and this shield for use, then I can just go ahead and use and read the data from this shield. So code like this would typically be represented as a library that usually the shield manufacturer would offer you and say, hey, here's the library, provides a nice class that you can just kind of say, shield.temperature, that sort of thing, and be able to read those values out. If I switch over, I just wanted to show you how I might be able to read a property from that. So you can see this thing has a property, this class has a property called raw pressure. And now you're getting into kind of hardwaresville, where it begins to look like, well, if the high bit is this and the low bit is this, so now I'm getting some specific data from this particular shield sensor. And I'm interpreting that data here as, in this case, a raw measure. If I just kind of scroll forward here, just want to show you a couple more things. I found it was interesting that the altitude was a calculation of barometric pressure. So when you see this application run, sometimes you'll see that it looks like we're in Death Valley because it'll show us below sea level. And that's because it's not really using a GPS to measure altitude or anything like that. It's just using a default calculation based on barometric pressure. Scrolling forward. So what we've done here is created this shield class that encompasses all of these attributes on the shield. And then we have this weather data structure. We're going to use this weather data structure to package up this data and be able to show it in the user interface or do other interesting things with this application. Now, the way we've got this working, it's kind of interesting. We're writing all of this data out to a file. So it's kind of old school synchronization. The data reading sits in a continuously running background task. It's a universal platform capability to have this task on my IoT device that always runs, that never goes away, just keeps running. And that's what's reading the sensor values about once a second. And then periodically, or for each reading, in fact, we take that and we store it away to a file. And then the user interface for this application, which I'll show you, simply looks at that file and then outputs the contents of that file to be able to say what the current values are. Let me see. Yeah, there's a piece of this that I want to show you that has to do with the cloud, but before I do that, I just want to run this piece. So running it really is as simple as hitting F5 or clicking the green arrow in Visual Studio. This is a Windows computer, this little Raspberry Pi. So things like remote debugging that we kind of take for granted in the Windows world, those things, we can continue to take them for granted in the IoT world. So I'm just going to hit the button here, get this guy running. It would be great if we waited until this worked, and then it would be a more appropriate time to clap. And then let's switch over to input 5, and let's make sure that this guy's running. So hey, there's the app. The app is actually running. That's a good thing. Okay, now's the time. Thank you. So it's good. The application's running. You can see the clock's ticking. I'm getting data in real time. That's fantastic. I'm going to let this run for a little bit and gather some data. And meanwhile, I'm going to pop open a website here. The application part is easy, but the typing the right thing into Internet Explorer thing is much harder for me. OK. So what you see here is an open source project that we've developed at Microsoft called Connect the Dots. I'm using Connect the Dots as a very easy on-ramp into the Azure IoT infrastructure that Sam and his team are building. So this gives me a very easy way to take these properties that you saw me collect on this device. It packages them up into a JSON document, and then it sends that via REST API calls through a set of libraries that Connect the Dots offers, and then makes it really easy for me to just kind of send this data up. So you can see I'm collecting data right here as time goes forward. It's a little. Let's see if I can perturb the data maybe by blowing on this thing. Let's see. Yeah. Okay. It looks perturbed. I had garlic for lunch, so I would be perturbed too. Actually, you could see an interesting bug here, which is at about 120, the humidity flips over back to 0 again, so that's why you see the weird drop in the graph. So this data is going from my machine, again, through REST API calls. It's a JSON document. It goes in through Event Hub, which Sam described to you. And then from Event Hub, this gets put into Stream Analytics, and it also gets put into Azure Machine Learning. And so using machine learning, you see some little polka dots appearing on this graph. If I were to hover over these, what this says is that this polka dot is an anomaly in the data detected by Azure Machine Learning. So I started this. I let it run for a little bit. It learned as it was collecting data what sort of normal looks like. And then as I blew into it, I created some conditions that made it look not normal anymore. And so that Azure Machine Learning kind of flagged that and was able to then report back to me. And had I not blown into this, that would maybe give me reason to pause. And I think this is a common pattern we're seeing with customers,
Very
is to
common.
do anomaly detection,
Yep.
predictive maintenance through machine learning.
That's right.
OK, and let us switch back to slides. We talked about all join a little bit earlier, and again, Gavin did a session earlier. This is the idea that no matter what kind of device I had and no matter who makes it, they should all just be able to work together in a secure way. And can you advance me? Mm-hmm. And then one other thing I wanted to mention to you guys is this idea of complete lifecycle management. From the time I enroll a device into my enterprise, it included as a part of my inventory, configure it, manage the software that runs on that device, provide assistance if something goes wrong with that device, and finally take it out of my inventory after a period of time. We've got both the support within the operating system as well as our tools with System Center and Intune, or third-party MDM tools. This all happens over open protocol called OMADM. So you can manage all of these devices in a very consistent way. And to learn more, a few sessions I would point you to. One is Kira Richardson's session on all of the IoT devices, all of the Windows IoT editions. My session tomorrow, which will be more focused on the makerspace. Retail session I mentioned, which is on Friday. And you can catch Gavin's session on the recording.
All right. That was great, Steve. So my little board went to sleep. It's now back up. You can come up and take a look at it. It really highlights the need to be able to remotely manage these devices. Oh, I'm being told I can show it.
OK.
All right.
Take it to screens.
All right. So now I'll push my button and go back over to, did it wake back up yet?
It's changed on here. I can see it.
Good. Looks like this thing went to sleep again.
It appears that drinks have gone from
Drinks have gone from $1 to
free.
free. Yeah.
That's my kind of embed device.
But this really highlights the need to be able to remotely manage devices, because this isn't something you'd want to go, roll a truck for. You'd want to just go send a signal. There it is. OK. We just got the signal. All right. So ending on a happy note. Thank you all for coming. We've got a bunch of great stuff coming up in IoT that we'll be disclosing later this year as well. We appreciate all your support, and have a great build.
Thank you.